Welcome to the first grade 9 physics chemistry podcast. This will be the first of many as we work through the year and we investigate the flip method of teaching. We're going to firstly look at recording experimental data, which is something we'll do very often, and we need to get into the habit of recording experimental data in a very clear way. In experiments, we'll always have variables, and the two main variables are the independent variable and the dependent variable. And these are the two variables that we could also call the experimental variables. So, to keep things organized, we record our experimental data in a data table. In the data table, the independent variable appears in the left column and the dependent variable appears in the right column. So let's draw up a data table, a typical data table. So I have on my smartboard the ability to draw straight lines. You can draw straight lines with a ruler, of course. So here we go. Here's my data table taking shape, like so. Two columns. We have the independent variables column on the left and the dependent variables column on the right. The dependent variable column, I want to divide that up into three sections, like so, because as a good scientist, I'm going to record my data 3 times. I'm not going to trust just one set of data. So this data table here is a typical data table where we can have the independent variable on the left column and the dependent variable on the right column. Now let's imagine we're doing an experiment to see how the height from which we drop a ball affects the time it takes for the ball to fall to the ground. Something a bit like this. So we have ball, there's our ball, and we have our ground, something like this, and we have the height. There's the height. Now the height is going to be our independent variable and the time is going to be our dependent variable. The time it takes for the ball to do this from different heights. So let's go back to the data table and put a few titles in. Independent variable, the height, how high you drop the ball from. So I'm putting that in there, height, and I'm going to include a unit. Standard units, always best, meters. The dependent variable is the time it takes for the ball to reach the ground. So I'm going to put time in my header here, again with units, standard units of time, seconds. So what about these 3 boxes here? Trial 1, trial 2, and trial 3. As a good scientist, I'm not going to trust just one set of data. I'm going to repeat my data, so I have 3 sets of data. Then I can take an average of my data to see what the best value for time is. So I'm going to choose some suitable heights ranging from, let's say, 0 meters or 0.1 meters, 0.2, 0.3, 0.4, 0.5, 0.6, and so on. A suitable range of heights for my experiment. And as I go along, I'm going to fill in the data in the data table. I'm going to do trial 1 with my stopwatch, and I'm going to find it's quite a small amount of time, 0.05 seconds maybe. And I'm going to go ahead and I'm going to record all the data. When I've collected all my data, as I said, you can work out the average, and you'll be ready to process the data in some way. Now, the most obvious way is to work out the average values of your falling time, and you could put this data into another data table. Now, this data table is going to look similar, but we will need a column for the average value instead of just the raw data. Average time, still measured in seconds. The first column is the same as the first column in the original raw data table. This is like the index or the key to the table. It links the two tables together. So the first column's heading is still height in meters, and it will contain the same data. 0, 0.1, 0.2, 0.3, etc. Once you've worked out the averages by adding the three values together and dividing by 3, we'll be ready to graph that data. Now, we can use graphing programs such as Microsoft Excel, which is a very simple program, and how to do that will be the subject of the next mini podcast.